Alrighty, everybody, here we are again. I want to formalize now the vertical stretch and the vertical shrink. How to recognize, right? How to recognize an equation, right? That is a vertical stretch of a, quadratic function or a cubic function or what have you. And the same thing with a vertical shrink. So let's get the general form down here, right, for a vertical stretch. And then I think I'll get into the horizontal after this. So to recognize a transformation that is a vertical stretch, right, it had to do with that coefficient in front of the x squared term, right, to get those y values further away from the x-axis than the original y values, right, from x squared. And yeah, that number was, what was it, 4, right? We times that by 4, and that's what got it further away. So yeah, a vertical stretch will happen. All right, if you have some function here, f of x be, absolute value of x, or, x cubed, okay? And if you multiply it by a number here, c, your constant, that's greater than 1, right? If c is greater than 1. Okay, that will be a vertical stretch. And they say by a factor of whatever that, by a factor of c. Okay. And I'll get into the writing when we start doing questions. And now a vertical shrink. Also known as a compression. Will occur when you have, a number here multiplied by the function. Now, once again, vertical shrink, those y values get closer to the x-axis than the original y values, right, of the original function. With the corresponding x's. Like I was saying, like 2, 4 is a point on x squared, and then 2, 1, right, was the point on 1/4 x squared, right? So with that same x, right, the y value on 1/4 x squared is closer to the x-axis than the original, right, than the original graph, the original function. Now, what caused it to get closer, to the x-axis than the original was the number it got multiplied by, right? By multiplying the y values of x squared by 1/4, caused those y values to get smaller, thereby getting it closer to the x-axis, causing it to be compressed vertically. So if your c value here, now people will say, oh, it's got to be, it's got to be less than 1. Well, remember, be careful here. Not just less than 1, right? Not just less than 1. It has to be a fraction or a decimal between 0 and 1. Right? if your C value is between 0 and 1, then it will shrink vertically by a factor of C. That's a vertical. That's the general notation there for a vertical shrink or a compression. Right, because the moment you get to like negatives, then, what are we doing there? Right, if you start saying negative, what about negative 1/2? Well, the moment we start getting into negatives, which will happen, that gets into reflections. That's a reflection, in the x or the y axis. So that's why it has to be between 0 and 1, and not like negative 1 to 1. If you're thinking about that, negatives, remember, deal with reflections. All right. I guess let me knock out the horizontal, might as well. All right, so I'm going to do horizontal here. So I'm going to set it up very similar to what I did here with the vertical stretch. I'll make a y-axis here. And an x. And I'm going to work off of x squared again. So, negative 3 to 3 for x. And, these y values we know, right? 9, 4, 1, 0, 1, 4, 9. No, I'll text you when I'm done. Yeah. So let's see here, right? So that's x squared again. 2, 4, negative 2, 4, 5, 6, 7, 8, 9, 3, 5, 6, 7, 8, 9, 3, 9, negative 3, 9. Okay, so here we go with the horizontal, all right? So just follow along with me here, when I do the notation for this, how I write it. So what I want to do next is x over 1/2 squared. X divided by 1/2 squared. And there's a reason why I'm writing it like that. You might be like, well, why don't you, just write it whatever x divided by 1/2 is. Why don't you just write it like that? Well, there's a reason, And I want to do that from negative 2 to 2. I'm not going to do the negative 3 here, or 3 for x divided by 1/2 squared. All right. So, like when x is negative 2, negative 2 divided by 1/2 is negative 4, and then squared is 16. Negative 1 divided by 1/2 is negative 2 squared is 4. 0 divided by 1/2 squared is 0. 1 divided by 1/2 is 2, squared is 4. 2 divided by 1/2 is 4, squared is 16. All right. So I'll plot them up again, right? 0, 0, 1, 1, 4. Symmetric with respect to the y-axis. So you could do negative 1, 4, and then 2, 16. All right, that's 9 there, right? 14, 15, 16, okay. And then, once again, bounce it off. Okay. the y-axis, and there you go. So this is x divided by a half squared. All right, so, for those of you that were thinking, right, when, I did the vertical stretch and shrink before, when I was asking you, well, what do you know about this graph here, right? And you're like, oh, it's more narrow compared to x squared. Well, all right, so let's think along those lines now. All right, let's do that here. X divided by a half squared is narrow, more narrow than y equals x squared, right? It's narrower. So in terms of a horizontal point of view, these points on x divided by a half squared, right? 0, 0, 1, 4, negative 1, 4, 2, 16, negative 2, 16. They're closer to the y-axis now, right? They're closer to the y-axis than their respective points on y equals x squared. 1, 4 is closer to the y-axis than its respective y value point here of 2, 4, right? Same thing on the other side, right? Negative 1, 4 here is closer to the y-axis, than its respective point that has a y value of 4, and that's negative 2, 4. All right, so those points are closer to the y-axis, meaning horizontally, x divided by a half squared got compressed or shrunk, right? Compared to the graph of y equals x squared. So this is a horizontal now compression, or you can call it a shrink. And once I get done with the graphs and stuff, I'll explain what you guys will need to do by looking at an equation to determine if it's a horizontal stretch or a shrink. All right. Now I want to do x divided by 2 over 1 squared. X divided by 2 over 1 squared. And you might be just saying to yourself, isn't that just x divided by 2 squared? That answer is yes. Well, once again, there's a reason why I am writing it like this. So x divided by 2 over 1 squared, I'm going to do negative 3 to 3. So negative 3 divided by 2 over 1 squared is really negative 3 times a half squared. Negative 3 over 2 squared is 9 over 4. Or 2.25. X divided by 2 over 1 squared. Okay. Negative 2 divided by 2 over 1 squared is, negative 2 times a half, which is negative 1 squared for 1. Negative 1 divided by 2 over 1, or negative 1 times a half, is negative 1/2 squared. is 1/4 or 0.25, and then we get 0, and then you probably see it now, 0.25 when x is 1, 1 when x is 2, and 2.25 when x is 3. All right, so let's plot these. 0, 0, 1, comma, 0.25, negative 1, comma, 0.25, 2, comma, 1, negative 2, comma, 1, 3, comma, 2 1/4, and then negative 3, comma, 2 1/4. So this is x divided by 2/1 squared. And if you take a look, at these points now, right? The points in green they are, and then the question I asked last time is, what happened to this graph? And, it was like, oh, it got wider, right? And yeah, let's think about that here. It did get wider from a horizontal point of view, right? Those points in green are further away from the y-axis than those points in red. Look at, with the respective y values being the same. So like, what's on a point on the red is 1, 1, right? You got 1, 1, and then on green you got 2, 1, right? See how that's further away than, from the y-axis than the original. So horizontally that got stretched out. Right, that's a horizontal stretch. Now, you might be thinking to yourself here, well, is that the same as, a vertical shrink, right? For this scenario, yeah. So we'll get into that as we, move along as well in this unit. Our horizontal shrinks equivalent to vertical stretches, and our horizontal stretches equivalent to vertical shrinks. And sometimes, yes, it is. All right. Obviously, the ones that I picked out here today with the x squared and, 4x squared and x divided by half squared, because these graphs are the same, as the one from above, up here. So it depends on the function, that I give you, whereby a vertical shrink is equivalent, to a horizontal stretch and vice versa. All right. All right. So what do I want to do here? Let me give you the general notation for the stretch and the shrink, and then I think we'll be good here for today. And this is the last of the transformations. There's no more new transformations now after this. So you got your shifts, you got your reflections, and you got your stretches and your shrinks. All right. So the general form here for a horizontal, I will start with a stretch. All right, it's going to look like this. The f of x divided by c. C is your number. will be a horizontal stretch if your C value is greater than 1. So you see how in a horizontal stretch the number is in with the x, just like in a horizontal shift. So you'll hear me talking about that as well. You know how to identify a horizontal stretch shrink compared to a vertical stretch or a shrink. Well, it's much like what we do with a horizontal shift and a vertical shift if the number is in with the x. And then a horizontal shrink or compression, same thing. It's going to be the f of x divided by c. And if your C value is between 0 and 1, that will cause the graph to shrink horizontally. All right, there's more to talk about with this, but this is the introduction to it. So I believe there might be a vertical stretch or shrink with the homework, today, which is part of the reason why I did this. But there's definitely more